Good morning, dear students. I welcome Dr. Deepak Bhope sir, Professor and Head of Mechanical Engineering Department. Let me introduce sir. Sir is graduated in 1996 and post-graduated in 1988, and he has completed his PhD from Vishweshwarya National Institute of Technology, Nagpur in 2005. He has rich teaching experience of 32 years and he has guided 6 PhD students. He has many research publication to his credit. He has more than 78, he has published more than 78 research paper in international journals and conferences. He has awarded 4 patents and awarded best mechanical engineering project. I welcome you, sir. Now I request Dr. Deepak Bhope, sir, to start his presentation. Thank you, sir.
Thank you very much. Yeah. Very good morning to all the students. Along with the students, I think the parents might have joined. Then all the faculty members who are listening to the presentation, and especially to Dr. Busari sir and Dr. Deshmukh sir for making this happen. Actually, one of the purpose of this induction program, okay, which is a week-long induction program, the purpose is nothing but is to acquaint the students, okay, with the college and at the same time with the broad areas of engineering along with the curriculum. So myself, Dr. Deepak Bhope, the professor and head of Department of Mechanical Engineering, Bajaj Institute of Technology, Wardha. I welcome all of you on behalf of the Mechanical Engineering Department. Without wasting any time, I think I can start the presentation. Now, today's presentation, I'm going to cover a few points. So this is the outline of my presentation. Initially, I will just explain you with the definition of the engineering and especially the mechanical engineering. Then I will present you the subject spectrum of mechanical engineering, which are the broad areas which comes under the mechanical engineering. Then what is important is that later on after the graduation, you need to work in the industries. So I will just highlight some of the major mechanical industries and the associations which are working for mechanical engineering. Then in brief, I will explain the mechanical engineering course curriculum. And at the end, I will give you some information about the mechanical department of DIT. I hope I am audible to all of you. There is one quote that if you want to save a person, be a doctor. And if you want to save the world, then become an engineer. Actually, the engineers are nothing but these are the creators. Engineers makes the things happen. They create the appliances, they create the things, which can be used by the human beings. In medicine field also you'll find many of the equipments. They have been developed. CT scan machines. The ultrasonic, the X-ray machines. So basically you will find they have been developed by the engineers. So engineers are supposed to be the creators, but you cannot demean the role of the scientist. In the development of the technology, we'll come to that during the presentation. Now we'll see what is the origin of the word engineering. Basically, it is the Latin verb, ingenium. Ingenium, it means to be clever. Dear students, all of you, you have joined, for the engineering degree at DIT. So, as you have joined, you have chosen engineering as a profession. So, all of you are the clever and you are the creators also. So, the kind of things engineers have done have been generally ingenious. And the word engine means an ingenious and useful device. So what basically, okay, the engineers do, they create, okay, they remain creative, and at the same time, okay, through their creation, okay, they create, okay, the useful devices which the human beings can use for betterment of the life. If you look at the development of engineering, it is said that, okay, the wheel has been developed, okay, nobody knows when it has basically originated. It is basically, roughly, it is estimated that near about 3,500 years okay, before Christ, that is 3,500 BC, okay, the wheel was invented. And later on, you will find the wheel has taken the various shapes. It has been used for the bullock carts, and now you can see, okay, the cars are running on the wheel, or I will say that the whole world is running on wheels. Okay, so engineering has been a very important area of study throughout the human history. It has helped the man to surpass various obstacles on his road to success. So actually, whenever there were obstacles, okay, if you look at right from the beginning, okay, there was the engineering, okay, with the human civilization. But the things were nothing but, or the devices which they invented, which they did, they are meant to make their living quite simple, quite comfortable. So the engineering, you cannot separate the engineering from civilization. Engineering was there right from the, the start of the civilization. If there are no engineers, okay, if there would not have been engineering, then a world without engineering would have been the world without cell phones, MP3 players, video games, televisions, telephones, cameras, and so on. The list is unending. So the role of engineers is very, very important, okay, in the creation of the things. Now this is just a cartoon, okay. So how can be the world without the engineers? So this is a self-explanatory cartoon, and you can just enjoy this. Okay. Now, along with the scientists, okay, along with the engineers, there are also the scientists. Now, you need to know what is the difference between the what the scientists do and what the engineers do. The scientists basically they study the world as it is, and the engineers they create the world that has never been. So that is the difference. Scientists try to understand the nature. Engineers try to make the things that do not exist in the nature. But the role of the scientist is very, very important. There was a scientist, okay, basically he was a physicist, the Feynman. He has given the lectures in many of the universities, and all these lectures are later on they were compiled to form a book that is the lectures on physics, Feynman lectures on physics, which engineers read. In old days, there was no as such the engineering discipline, and the physicists, okay, used to do the role of the engineers. Actually, what the scientists or what the physicists do, they do observe the nature, because everything is existing in the nature. What you have to do, you have to observe the phenomena. Okay, you need to decode the phenomena, how they are happening, and all these phenomena they need to be put in the form of the theory. That is nothing but basically it is a task of the physicist. But later on, it is felt that how this theory it can be used, or how this theory which has been developed by the physicist, okay, how it can be converted into the technology. And there the engineer's role came into existence. So it was a transformation from basic theory to the technology. If you just take the example of the James Watt, you know that the James Watt, okay, he has invented the steam engine long ago, and basically it has changed the total world. But the while developing the, actually James Watt was the machinist. Okay, you can call him as the engineer of that time. He was the machinist. He was very expert in fabricating the things, doing the things. But the basic theory behind the steam engine was the thermodynamics. But he was not knowing the thermodynamics. So he took the help of Joseph Black, who is the physicist. And by knowing the principles of the thermodynamics, James Watt, he developed the engine. So basically, if you look at how the technology has been developed, is nothing but it is due to the close association between these two people, the scientists and the, the engineers. If you look at the mathematicians, they have developed the theory, okay, 100 years ago. Many of the equations, many of the theories, many of the solvers, okay, they developed. But these solvers, okay, they could not be used, okay, because of the lack of the computing power. But due to the advent of the computers now, it is possible to apply all these theories which have been developed by the mathematicians. If I consider the example of, let us say, finite element analysis, the variational formulation has been done long, many years back, but that has been now used, okay, for the finite element analysis, okay, and that is being used by the mechanical engineers. So in the development of the technology, okay, the role of the basic sciences is very, very important. Okay, that I want to just put it on this particular platform. Now I will go to the engineering. What is mechanical engineering? So mechanical engineering, it focuses on the design, manufacturing, and maintenance of the machinery. So the basic, the broad areas in the mechanical engineering is nothing but design, manufacturing, and the maintenance. And this mechanical engineering, basically, it is the broad type of engineering. It is the second largest discipline, it is said. The first largest discipline is the civil engineering, and second is the mechanical engineering. And the mechanical engineering, it covers everything from designing the cars to building the robots to building the satellites also. Okay, right from the micro things. Okay, they can design. Okay, the the models which are on. Now the mechanical students basically who will particular subject, and after your degree you can begin your career in all kinds of space, automotive engineering, nuclear engineering, construction, and defense, major fields. Also, you can end up working at the forefront of new technologies because mechanical engineers are needed to develop new and more efficient ways to generate the power, improve the transport system, and to enhance the quality of life around the world. So you can do a lot after your graduation. If we look at the broad areas of the mechanical engineering, then the mechanical engineering, it consists of mainly three domains. The first domain is the thermal or the thermal sciences. The second domain is the design or mechanical design. And the third domain is the production of manufacturing engineering. Under each and every domain, okay, there are many subjects, only few subjects are included. Okay. Let us see in the thermal domain, thermodynamics, heat transfer, energy conversion, and the fluid mechanics. In mechanical design, you can see the subjects like from statics, theory of machines to, let us say, machine design. And in the production or manufacturing engineering, you can see the subjects from manufacturing to automatic controls, metallurgy, up to engineering economics. We'll go deeper into the subjects one by one. Okay. We'll initially start with the thermal stream, then we'll go to the design stream, and then we'll go to the production stream. Okay. So initially we'll now start with the thermal or thermal sciences. In the thermal or the thermal sciences, already we have seen the subjects. The first basic subject, okay, is nothing but it is the thermodynamics. The thermodynamics is nothing but basically the transformation of the energy into the work into the energy. So to do the useful things, okay, or we need to convert the energy, okay, or the heat into the work and work into the heat. There are principles are there, thermodynamic principles. This subject is something you can say it is a philosophical subject, okay, which has many laws, okay, many cycles also. We call them as the thermodynamic cycles, and it is the base subject or the basic subject for the thermal engineering. So this is the subject thermodynamics, okay, which is very useful, okay, in thermal engineering. If you want to understand the complete thermal engineering, then you must have the mastery over the thermodynamics. The second subject or the second area in the mechanical engineering, which comes under the thermal side, is the heat transfer. Now, let us have very simple example how you, let us say, heat the water in the pan. Now here you'll find here there is a burner, okay, or maybe the coal is burning, okay. Now the heat from this coal, okay, from these flames, basically it is getting transferred to the pan, okay, it is a metallic pan by means of the radiation. Now you know that, okay, the bottom portion of the basically the pan will get heated, and the water which is in close contact with the bottom of the pan, okay, will receive the heat, okay, at the first time. And later on, what will happen as the heat, as it receives the water, will, when it will receive the heat, okay, its density will decrease. So the hot water will try to go to the top. While doing so, okay, the water itself will transfer the energy, okay, and this process continues, okay, and you'll find that after some time, okay, the entire water, okay, it has reached to certain temperature. So this we call it as the convection, okay. Let us say if you hold the pan for longer time, okay, there is a handle is there, okay, which you are holding. Assume that it is metallic, and after some time you will feel that, okay, this handle also becomes quite warm, okay. So actually what is happening, you are not hitting the handle, you are hitting the pan. So the heat which is there, okay, received by the pan, it is nothing but it is getting conducted to the handle, okay. So this is the very simple example where you can just learn radiation, convection, and the convection. So in the mechanical engineering, okay, this subject heat transfer is also very important. The next subject in the thermal side is the energy conversion. Energy conversion means transformation of energy. You know that energy cannot be created, cannot be destroyed, but you can transform the one type of energy into the another type. Now this is the very simple example. Okay, this is the battery cell and this is the torch. Now the battery cell do have the chemical energy, but when you put it into the torch, okay, then what happens? This chemical energy, okay, is utilized, okay, to light the lamp. Okay, so it means that the chemical energy can be converted to the light energy. But when you use the solar panels, okay, then the light energy can be converted into the electrical energy. Okay, if you see the real life example, okay, the trees are receiving the energy from the light, okay, for the photosynthesis. So always there is the energy conversion which is taking place. Okay, so here in case of the mechanical engineering, okay, we'll see how the heat energy can be converted into the work. Okay, because we need to, because let us say if the engine has to work, okay, if the automobile has to run, okay, mechanical work need to be done. And to do the mechanical work, okay, you need the heat energy. Okay, let us say if you consider the example of the missiles also, okay, missiles use the energy, okay, and it is getting converted to the work because they move from the ground to the certain elevations. The next topic, or next field in the thermal engineering is the fluid mechanics. So fluid mechanics is nothing but it is the study of the fluids. Fluids means basically both are there. liquid and the gases. And it involves the study of various properties of the fluids. Now here you can see one graphics. This is the graphics of the river. Okay. Now you will find that here the flow is quite steady. Okay. Water is flowing, but here the flow is steady. We call this as the streamline flow. And here in this region you can see there is a turbulent flow. Okay. Some turbulence you can see. Okay. So we call this one as the laminar flow and this one as the turbulent flow. Why it has occurred? There may be some retaining wall of the low height which may be placed here, okay, to maintain the water level. And when the water it flows over the retaining wall, it becomes turbulent. Okay. Now, so here we'll study the behavior of the fluid. Okay. Now, one example is, okay, during the landing, during the takeoff, okay, there is a lot of air resistance which is being offered to the aeroplanes. So you can study the wind resistance, okay, or the nature of the flow around the aeroplanes by using the fluid mechanics. You can design the body, okay, or the shape of the, let us say, car, okay, by knowing the principles of fluid mechanics. Here you can see it is aerodynamic. We call it as the aerodynamic shape. Okay, so there is no turbulence which occurs. Okay, the next part is nothing but it is the design or mechanical design. So first is thermal is over. Now we'll go for the design or the mechanical design domain of mechanical engineering. Now the first subdomain under the design is the dynamics. So basically, dynamics is nothing but it is that branch of area of machines which deals with the study of various forces which are involved in various parts of the machine. When the object is moving, you can say. You must have enjoyed, all of you must have enjoyed, I think, okay, the ride in the roller coasters. And when you ride in the roller coaster, you you actually experience, okay, some, you can say, um, some unseen forces, I call them. Okay, some unseen forces. Unseen means actually they are not directly acting you, but actually they are developed. Okay, why they are developed? Because when you do the coaster ride, the roller coaster ride, the direction of velocity is continuously changing. Okay, at the same time, the magnitude of the velocity is changing with respect to time. That means acceleration is there, and another thing is again the deceleration is also is there. Okay, it is controlled deceleration. So by changing whenever, let us say, the force changes the direction, okay, or whenever the motion of the body, okay, it changes, let us say, in velocity or in acceleration or in retardation, okay, you will experience some magical forces. And these magical forces are nothing but we call them as the G forces. Okay, so in dynamics, in the machine dynamics, we'll see, okay, how the components behave when they are in motion. Next, another sub branch or the subdomain under the design stream is the vibrations. So this is the very good subject, okay, which each and every mechanical engineer should study. All of you have the mobile phones, okay, and these mobile phones you put in the silent mode, and like you can put in the silent mode, and at the same time you can put them to the vibration. When you put in the vibration mode, okay, and when you receive the call, then the mobile starts vibrating. Okay, you'll find that if I place the mobile at one place on my table, okay, it moves, okay, to the other place. Actually, why there are the vibrations? How the vibrations are created in the mobile? Is there any some electronic thing which is causing the vibrations? No, it is a mechanical thing. If you look at now here, okay, in the mobiles, what happens? This is the PCB of the mobile, and this is the electric motor which is there. Here you can see some enlarged view, and this is the motor. Okay, and you will find at the end of the motor, okay, there is one unbalanced weight. Okay, you will find the weight is only on one side. So whenever the mobile is in the silent in the vibration mode, okay, there won't be any ring, but this motor will start rotating. And as the motor will start rotating, okay, what happens? Okay, when this weight will run, okay, it will rotate. The centrifugal force, it will change its direction. Okay, so here, what is happening? The force is remaining constant, but its direction is changing, and it is creating vibrations. It means that whenever there is an imbalance, okay, in the machinery, it creates the vibrations. Okay, so this is the subject, okay, which is very important, okay, from practical point of view. If you let us say look at these two graphics, okay, here you will find the graphics of the um, MSRTC bus, and here you can see the graphics of some luxury bus. Okay, what is the difference? If you take a ride, let us say in the MSRTC bus, and if you take a ride, let us say, okay, in the luxury bus, the difference is that when you let us say when you travel or when you make a journey in the MSRTC bus, okay, ordinary buses, I will say, okay, you will feel they are uncomfortable. All the vibrations, all the jumps, all the bumps, basically they are getting transferred to the passengers. But in case of the luxury buses, okay, no such thing happens. Actually, both of the buses they are running on the same road, okay, but there's a difference in the designs. Now, which component comes into play? Okay, as far as controlling the vibration, it is the suspension. Actually, the roads are uneven, okay, but the passenger who is sitting in the bus, he should not feel that unevenness, okay, or he should not feel the shocks. So the suspension system that has been designed for the luxury buses, okay, it is nothing but you can say it is a high-end suspension system, okay, where a lot of engineering is involved. But if you look at the buses, okay, normal buses, okay, ordinary buses, okay, the suspension is not that good, okay, it's a crude type of suspension. So you can see that, okay, it means that to reduce the vibrations levels, okay, to reduce the shocks and the vibrations, you need to study the subject of vibration. The next subject in the design is the machine design. It is a very, very basic subject in design. The machine design is nothing but it is the creation of plans for machine to perform the desired functions. So if you want to design anything, let us say if you want to design the automobile, what is needed? Okay, the first thing is the requirement. Okay, for what you have to design the automobile. Okay, how much power it needs, and later on you start designing the things. There are many components, thousands of components are there in the automobile. Each and every component you need to design so that, and the designing should be such that it should not fail in service. So you carry out the design, you create the drawings. After creating the drawing, then you send it for the production shop to manufacture it. So machine design is nothing but the planning. So you create the plans for the machines. This is very, very important subject. The next subject in the design is nothing but it is a CAD, that is a computer aided design. Now earlier, all the designs they used to be done by manual process, okay, on the drawing sheets, they used to plan the things. But now with the advent of the computers and with the availability of many of the CAD softwares, it is possible to carry out the designs also by using the softwares. And at the same time, you can visualize its 3D view. Okay, you can rotate the things, you can see from all the sides. If you want to see the inside also of the machine, you can see the things. So the computers basically it became a boon to the mechanical engineers to visualize the things and to carry out the designs, to analyze the designs, okay, to uh, to carry out the modifications also, okay, in a very, very less time. So it has accelerated actually. Computer, what the computers have done, they have accelerated the process of the development. So this subject also, okay, will be studied in the mechanical engineering. So this is just an illustration. I have just put the graphics of the CAD model of the frame of the bicycle. You can see here the damper and other things. Yeah, shock absorber. This is also the model of the car body. Okay. Now the third domain, which is very important, is the production or manufacturing engineering. Because Let us say I have designed everything. It is on the piece of paper, but that need to be converted into the reality, and the persons who will convert into the reality are the production or the manufacturing persons. So these are production and the manufacturing engineering is very, very important. In the production and manufacturing engineering, we'll see the subject industrial automation and the robotics. If you look at back, okay, if you go into the old days, how the manufacturing was done on the assembly lines, it was totally a manual process. You can see, okay, the car is being pushed over the assembly line, and all the operators, okay, they are actually doing their task, intended task, or the assigned task, okay, putting the engine, tightening the bolts, putting the wheels, okay, all these things they are doing it manually. But the things have changed, okay. You can see now here, all the human beings, okay, or all the workers, they have been replaced by the robots, and the robots are doing the things on the assembly line, okay. So the robotics and the industrial automation has changed the world totally, or changed the manufacturing. The production can be done. The time required for the manufacturing has decreased a lot, and the accuracy has increased. Now, to have the assembly line like this, each and every robot need to be programmed. The process is not random. It is systematic procedure. What is to be done in sequence. Okay. So the robots are programmed, and for and here in this particular subject, you will also study how to program the things, program the robots. The next branch is nothing but it is the automobile engineering. I should not explain, I should not tell you much about it because all of you, okay, you know about the two-wheelers, the four-wheelers, the trucks, okay, the earth-moving machineries, okay. So everything comes in the automobile engineering. Now, what we are going to study in the automobile engineering, if you look at the car, let us say, it has a different components. Engine is there, transmission is there, okay. Then you will find, okay, there are the exhaust liners, the mufflers, okay, so many things. The car body is there, the controls are there, okay. So all this nothing but how to design all these things, okay. It comes under the automobile engineering. Next is very important, okay, is the engineering economics. Without the finance, okay, would like to become the entrepreneur, and let us say he want to start his manufacture the cars, assume that, okay, as an example. Then what he will do initially, he will plan the things, what he want to do, okay, in which segment he would like to manufacture, and then he will invest the amount. Okay, he will do the planning initially, he will invest the amount, and he will start the manufacturing. Okay, and this is the end product. Now this end product need to be sold in the market. So you need to do marketing and selling. Once you do the marketing and selling, it is necessary that you should earn the profits. That is very, very important. So the things need to be planned correctly so that you are in the profits. Some part of the profits, okay, it gets distributed to the shareholders of the company, and the large part of the profit is nothing but it is invested again on the manufacturing unit, okay, for the further development and all these things. Then only, okay, the manufacturing unit will run. If you have the less profit, you cannot run the manufacturing unit. Okay, so everything need the economic plan. Okay, it depends on your demand and supply. Okay, how much is the demand, how much is the supply, on everything you need to work. Here also you need to manage the human resource also. So all these decisions they comes basically under the engineering economic decisions. It's very, very important. Okay, if you want to become the entrepreneur, then this subject you need to study this, but let us remember this. The first thing is the effective technical skills that you need to learn. The second is nothing but it is ability to work under the pressure, because you need to deliver the things within a particular time. So the ability to work under the pressure is very, very important. Next is the problem solving skills. Okay, the problems are there, but when the problems are there are the solutions. And to have the solutions, you need to use your skills. Next one is the creativity, which is very, very important. Creativity only leads to creation of new things. Next is the interpersonal skills. That is also very important. Verbal and written communication skills. You must be able to speak. You must be able to write also. That is also very important. Next is the commercial awareness. What is happening around us? Next is the team working skills. That is also needed, because individual cannot do many things. He can do, but he cannot do many things. So you need to have the team, and the the teamwork basically it matters. So you should know how to work with team. In the project, let us in the final year project, okay, there's a batch, let us say of 5 or 6 students. It's a team, and one assignment is given to the student that do this thing. Okay. And all these 5 or 6 students they work on that, okay, as a team, and they come out with something. Okay. So there itself you can learn. Okay. But there are many opportunities which will be given by the department, okay, to improve this team working skill. And last one is the patience. Many times the things doesn't happen what are intended. Okay, you need to, okay, basically keep on trying, keep on doing the things, okay, and that requires the patience. So these are the essential qualities, some of the essential qualities I will say, okay, broad base. For mechanical engineering, not for the mechanical engineering, I think it is for all the engineers. Now, how to learn the engineering? Okay, I feel that, okay, through the books or through the teaching, you can get near about 40%. But from your engineering attitude, observation, and the practice, you can learn 60% of engineering. So anybody can be an engineer. What is important is the engineering attitude. I will just narrate one story of a roadside mechanic. Let us say if you are riding your two-wheeler and suddenly there is a breakdown. What you do? You just approach to a very near, okay, the roadside mechanic who is very near to you. You take your vehicle to that mechanic, and he just diagnose the fault, and he just make your vehicle ready, okay, so that it can run again on the road. Let us have a discussion with that roadside mechanic and ask him, okay, have you, that what is your education? Have you studied degree in mechanical engineering? Have you studied some books on mechanical engineering? He will say that, no, I have not done anything. 15 years, he will say that 15 years back, I started my journey with a senior mechanic. And on the first day, okay, he has given me the spanner and he told me to open a nut and bolt, okay, of a vehicle. And from that day, my journey as a mechanic has started. I used to observe, okay, what the head mechanic or the senior mechanic was doing. I just observed and I tried to practice the same on the other vehicles. Now I can diagnose I can repair the engines, I can open the engines, I can repair the engines, I can diagnose the faults. And whenever any vehicle goes on the road, I can diagnose that which fault is there in that particular vehicle. So how he has got this all the knowledge? He has not done any degree. He has not. He don't know anything from the books. Okay, he has not gone through the books. It is nothing but the power of it. It is nothing but his attitude of learning, attitude of observation, and practicing the things. So I give 60% weightage to this. So I hope, okay, you will remember this. Now, next, after your graduation, you need to do the jobs, okay, in the industries, mechanical engineering industries. So I have just mentioned some of the few major mechanical industries here. That is the pulp and the paper industries, like milk, sugar industries, tire and tube industries like MRF, Dunlop, textile, okay, machine tools, petroleum refineries, power plants, which includes thermal, hydel, and the nuclear power plants. Railways, they need the mechanical engineers. Shipbuilding, aircraft building, then automobiles and its components. Whenever any company is there manufacturing the automobiles, its components are manufactured, okay, by the ancillary units, okay, because the automobile contains thousands of components. It is not expected that the companies should manufacture it, but it outsources the things, okay, to the ancillary units and the manufacturing components. So there are many ancillary units, okay, which are manufacturing the components for many major automobile companies. Automation and robotics, cement plants, fertilizers, renewable energy in the renewable sector like Suzlon, okay. Then refrigeration and air conditioning area you can work, okay, like Blue Star. Many companies are Voltas. Then satellite and space shuttle building, missiles and defense equipment, earth moving equipments, foundry and forging, packaging industry, dairy, and the list is unending. I just mentioned the few of the major areas, okay, in which you can work as a mechanic, as a core mechanical engineer. Now we'll see which are the top mechanical engineering companies. Okay, NASA, National Aeronautics and Space Administration. So no introduction is needed for NASA. Next is the Siemens. So these are the nothing but areas basically what the Siemens does. So I will not go into the detail. Just you remember the name. I think that is enough now at this time. When you will come to or when the mechanical engineers will come to second year, okay, that time I may put some light on over the which are the products and which are the services, okay, which are being offered by all these companies. Larsen and Toubro, then Rolls Royce, which is basically it manufactures the engines for the aircrafts. Next, the Kirloskar. Kirloskar also manufactures the pumps. Engines also they manufacture. Thermax, which manufactures the boilers, the fans also they manufacture. Next is the Tata Giant. Yes, you know. Okay, they basically they work in the steel, they work in the automobile sector, okay, many areas. Next is the Suzlon, okay, which is nothing but it is the giant now in green technology. They actually design, erect, manufacture, and erect and commission the windmills. SR is nothing but it is the steel giant. Next to the GE Aviation, which also manufacture the engines for the aeroplanes and some avionics equipments. Next is the Ford. The first automobile, basically, it has been manufactured by the Ford. They do have the very diversified areas. Next is Adani, which is in the power sector, in the mining also. Okay, the Adani group is there. Next is the Boeing, which manufactures the aeroplanes. Next, DRDO also require the mechanical engineers. That's the defense R&D organization to manufacture the defense equipments. NHPC, National Hydel Power Corporation. So they are working in the hydel power, and just recently they have established 145 megawatt unit in the Ladakh. Because you will find that the hydel power plants are mainly in Himachal because it needs some difference in the heads. Okay, so at those places only, okay, we can have the hydel plants. ONGC, the giant in oil and natural gas. ISRO, no introduction is needed. Mahindra, okay, they do have again the diversified sectors. Okay, we have the vehicles, tractors. Okay, everything is nothing but it is manufactured by Mahindra. Triple Land, they manufacture. They are giant in manufacturing the trucks, buses. Next is BHEL, Bharat Heavy Electricals Limited, and uh, they manufacture. Let us say from the mechanical point of view, they manufacture the turbines, boilers also they manufacture. Then Bajaj, which is distinctly ahead, and you should be proud that okay, you are the part of this Bajaj group as you have taken the admission in the IT. Bajaj has that very diversified area. You know Bajaj Auto, you know Bajaj Finance, you know Bajaj Alliance, okay, Bajaj Finserv. So mutual funds. So Bajaj basically is there in each and every page. Okay, right from automobile to the finances. It's a diversified group and it's a progressive group. Okay, so this is also a giant basically, which uh, which basically recruit many mechanical engineers. And we are proud to be now the part of the Bajaj group. Now, along with these industries, okay, there are associations which contributes to the development of mechanical engineering. The associations are, I just mentioned the few important associations. Indian Society of Mechanical Engineers, Society of Automotive Engineers, SAE we call it, American Society of Heating, Refrigeration and Air Conditioning, ASHRI we call it, American Society of Mechanical Engineers, ASME, and the Institution of Mechanical Engineers. So all these societies, they are nothing but contributing a lot to the development of mechanical engineering. If you see the American Society of Mechanical Engineers, okay, they develop the codes for designs, for manufacturing. Okay. All these codes they have been designed nothing but by the ASA, which have been used worldwide. ASHRI develops the codes mainly in the refrigeration or heating and ventilation side. Society for Automotive Engineers, they develop the codes for related to automotive sectors. Okay, so these three societies are very important. Okay, as far as the development of codes, the standards are concerned. The Institution of Mechanical Engineers is the Indian society with the headquarters at Calcutta. It's a very large society and it's a very old society, and it contributes to the development of the engineering. By they publish the journals. Okay, they have the centers also all over India as the local centers where many programs are being held. Now let us look at the scheme of the first year and the subjects which, which are taken by the mechanical engineering department. Now this is the scheme of the first year. Already it must have been displayed to you, okay, from the first year side. In the first year, the mechanical engineering department will handle the two subjects, that is the engineering graphics and the basics of civil and mechanical engineering. So here the basic mechanical engineering will be handled, okay, by the mechanical department. So two subjects will be handled: engineering graphics and the basic civil and mechanical engineering. So it is not a full subject we are going to handle. We are going to handle only the half of the subject because we will cover only the mechanical engineering part. Okay. So these two subjects will be taught you by the mechanical engineering people. Now in the basics of the civil and the mechanical engineering, the mechanical engineering portion has been divided. Now we have the faculty members. Okay, Professor Pankaj Bise, Professor Moe, Professor Chandak, Professor Gohil, and Professor Varagade. And all these persons are expert in their areas. Professor Varagade is expert in the thermal engineering. Dr. Vikas Gohil is nothing but having the expertise in the manufacturing sector. Dr. Chandak in the design side. Samir Mulay, actually he had a lot of industrial experience in the automobile sector. So he is the expert in the automobile side. And Professor Pankaj Bise, it is the introduction to the mechanical engineering. So actually, by dividing the, because you need to have the introduction to the mechanical engineering, and the mechanical engineering it is composed of various domains, and each and every faculty they do have their own domains of expertise. So it has been thought that okay, the subject of basic mechanical engineering should be taught by the faculties as per the expertise. You keep on interacting, okay, during your subject, keep on interacting with all these faculty members, and they will also tell you about the advancement in the sectors. And I hope it will be a very interesting subject for all of you. Next, we'll go to the scheme of the from the second year to the final year of mechanical engineering. I'm not going into the detail. Okay, this is the course structure for the third semester. I will just go through the subject. You can see now, okay, fluid mechanics, thermodynamics, already we have seen. Okay, so these are the subjects in the third semester. It is available in the on the Deepak website. Then it is these are the courses for the fourth semesters. These are the courses for the fifth semester. Heat transfer we have seen that. Okay, machine design. All these terms now they are known to you. Automobile engineering. Okay. Next is the sixth semester. We have again the courses. IC engines. Okay, mechanical measurements. Renewable energy sources. Very important subject now. Then in the seventh semester, we have this CAD CAM. Already we have seen that the computers are playing the major role, okay, in the designing and crafting. So this subject is also very important. It has been included at the seventh semester level. Field machinery is also very important. So these are some of the subjects which are included at the seventh semester. And in the eighth semester, that is in the final semester, okay, there are no subjects which need to be taught to you, but you need to select the two subjects, okay, from the NPTEL list of subjects, okay, which have been decided already by the university. And along with this, you need to do the project. Okay, you can do the internship and the project. So you can choose the industry, you can work there, and you can do the project also there, or you can do the project here, and you can do the internship in the industry. So many options are available. So it will make you industry ready. If you do your project in the industry, okay, it will make you industry ready directly. And many of the many times it will happen that if you perform very well in the industry, okay, during your eighth semester, they may offer you the job directly. Okay, so this part is very important, and right from now, okay, each and every student, okay, should think of okay, this how I can do this in the industry. Okay, in mechanical engineering, okay, there are some specialization. Major, we call it as the major and minor. Major means actually during your graduation. Okay, if you do all these courses, okay, these five courses from the SWAYAM or NPTEL courses, that is from the NPTEL site. Okay, all these courses are related to thermal engineering. Okay, so if you do all these courses and if you earn the minimum credits, okay, as per the guidelines, then you will be given the degree as the BTech honors with the specialization in thermal engineering. Okay, let us say if you want to do the specialization in manufacturing engineering. Okay, now these are the subjects. If you let us say study all these subjects, if you do the examinations, okay, and if you earn the required credits, then you will get the degree as BTech honors mechanical engineering with specialization in manufacturing engineering. That means the specialization you can have it at the degree level itself. In earlier days, it was at the PG level, but now you can have the specializations also at UG level. So this is regarding the major. There is also another concept that has been put by DBA2, that is the minor specialization, minors. Now, each and every department has offered some courses which the students can do. Mechanical engineering has offered, let us say the computer science has offered the courses, electrical engineering has offered the courses. Now, let us say if the mechanical engineering, mechanical student is interested to do the courses in computer science, then what he can do, he can opt the computer science courses, the few computer science courses which are there in their list, okay, during his graduation, and he will get the degree that we take in mechanical engineering with minors in computer science. That is whenever, so if you do like this, then let us say if any a job opportunity comes to you from the in the software side, then you can say that I did my mechanical engineering, but I also have the minor degree in computer science. So you will be always at the advantage. But it requires the extra efforts. That is important. You need to do. You have to stretch yourself. You have to extend yourself. Okay. So that is important. Okay. So this is regarding the major and the minor degrees. Now I think the time is okay. Okay. In 10 minutes I will finish up maximum. Now let us visit the mechanical engineering department of the IIT. Okay, in the virtual mode now. Now the course which you are going to study in the Department of Mechanical Engineering is the BTech in Mechanical Engineering, having the duration of 4 years, 8 semesters. And this course is affiliated to Dr. Babasaheb Ambedkar Technological University in Pune. And the course has commenced in 2017 now. Okay, and the branch has commenced from 2017. But though it's a 4 years, okay, the batch is in the 4 years, the complete development of the academic units, the laboratories has been already done. And the intake is of 66, you know it. Regarding the faculty profile of mechanical engineering, we have total 9 faculty, including me. Okay, so this is the brief introduction about me. I am working as a head of the Department of Mechanical Engineering. And these are the qualifications, the research publications which have been mentioned here. My mobile number is there. The mechanical engineering students, they can just note down the mobile number and my email ID so that if they want to communicate anything, they can communicate. Next, we have Dr. Manish Pasarkar. His expertise is in the design engineering, CAD and robotics. His experience is 23 years. Next, Dr. Pawan Chandak. His expertise is in the design engineering, neural network modeling, intellectual property rights. Next, Dr. Vikas Gohil. He has the expertise in manufacturing science, that is production or manufacturing engineering or manufacturing sciences. Next, we have Professor Pankaj Bise. He has the expertise in the production technology and the engineering graphics. So, in the first year, okay, in your first year, Professor Pankaj Bise will be engaging your one subject, that is the engineering graphics. Next, Professor Mandar Gupte. He has the expertise in manufacturing systems. Next, we have Professor Suraj Vairagade. He has the expertise in thermal engineering. Then we have Mr. Santosh Kumar, Professor Santosh Kumar. He has the expertise in the machine design. He's also looking after the training and placement activities of the department and the internship activities. So if you would like to go as an intern, okay, you can contact Professor Santosh Kumar, very energetic fellow, okay, very good in communication with the students. So you can right from your first year, okay, uh, especially the mechanical engineering students, okay, they can speak with Professor Santosh Kumar what is to be done, okay. So you will always remain guided accordingly. Then we have some Professor Samir Mule. He is having the expertise in the automobile engineering, and he has the industrial experience of 8 years in the automobile sector. So, as far as the faculty profile is there, okay, very rich faculty profile, okay, the department possesses, and all of you will get benefited, okay, with the expertise of the faculty. Next, the department do have the laboratories and the workshops. Okay, this is the applied thermodynamics lab. So this is the steam power plant, which is the unique, okay, which is the unique setup we have in BIT, in many of the engineering colleges, you won't see such setup. It is a steam power plant complete, where you generate the steam, you run the turbine, and you generate the power. So it is the mini power plant. Okay, so demonstration, you can do the practicals here on this particular setup. So these are the different equipments which are there in the other equipments in the thermodynamics lab. So this is the basic mechanical engineering lab. I told you earlier that you have one subject, the basic civil and mechanical engineering, and this is the laboratory which has been especially devoted to that particular subject. Next is the engineering drawing hall. Okay, this also you will be utilizing during your first year, because the drawing sheets and everything you need to prepare here, and you will study the engineering drawing or the engineering graphics. Okay, in this particular hall, there are the models are there. Next, the department is having the fluid mechanics laboratory. Okay, the sophisticated models are there in the fluid mechanics lab. Already we have seen what is the role of the fluid mechanics. Okay, so here you can experiment the things. Next is the material science lab. Okay, which is also a very good addition is there. Here you can visualize the microstructures of the metals. Next is the theory of machines lab. Here you can study the basically the dynamics you can study here. Okay, in the theory of machines lab, there are various equipments which are available in the theory of machines lab. You can again do the experimentation, okay, and you can understand the phenomena. Next is the heat transfer lab. We have seen heat transfer is nothing but basically it takes place due to conduction, convection, and radiation. So you can study all this conduction, convection, and radiation by using the different experimental setups. So these are the various setups which are available in the heat transfer lab. Next is the metrology and quality control lab. Quality control is very important when you manufacture anything, and you need to check the quality before it goes to the market. So there are some equipments. Okay, there are some theories for the quality control. So we have the equipments. Okay, in that particular laboratory. Next is the refrigeration and air conditioning lab. Okay, so there are various setups out there. Okay, one good example of the refrigeration is nothing but it is the fridge you have in your household. Okay, but how the fridge works, how the air conditioner works, you can understand. Okay, from all these setups which are available in the laboratories. So these are the various setups. Internal combustion engine, your vehicle, your two-wheeler is having the engine. Okay, but how the engine works. Okay, so from engineering point of view, you can learn the engines. Okay, or you can do the practicals on the engines in this particular laboratory. Next, we have the manufacturing process lab, and in the manufacturing process lab, we have the CNC machines. So these are the CNC machines which we have. So CNC milling machine, CNC lathe. This is nothing but it is another setup, that is electrical discharge machine we have. Next, this is the 3D printer we have. You can manufacture any component. Intricate component can be also manufactured. Then we have the workshop. In the workshop, we have the various units: steel metal shop, welding shop, fitting shop, plumbing shop, carpentry shop, machine shop. Okay, so all these shops you will explore in your first year. And the department basically it encourages the students, okay, but they encourage the participation in various events. So these are some of the slides, okay, which are devoted for the okay the involvement of the students in various activities. I will just go through very fast because the time is actually it is running now. Already it is late. So expert talks also they have been conducted from the Bajaj Auto by the department. So Bajaj Auto is closely associated with the college for the exchange of the expertise. There are also the expert talks which have been basically delivered by the Honeywell International. Recently, we had the expert talk on the mechatronics. These are the companies in which the students have done their internships. There is a department club that is the Make BIT. which nothing but it conducts the co-curricular activities. So when you will come to the department, okay, we will be the part of this departmental club. And these are the webinars or the expert talks which have been carried out by the faculties of the department. So the last slide is why we always dream for an easy life. Why are we afraid of working hard? Why are we all scared of challenges and toughest competitions? After all, these are the only things which improves our performance and makes us better and better day by day. So, thank you very much. Yes, over to Deshmukh sir. Sorry for
Uh,
taking more
Thank
time.
you, sir. Uh,
Thank you, sir.
Thank you. Yeah. Thank you. Yeah.
uh, Disha, please start put
Disha,
of
please
time.
start put of time.
Am I audible, sir? Hello.
Yes, yes.
Yes, yes.
Yes,
Okay.
sir.
Good morning, sir. I am
Good
okay.
morning.
Okay. Thank you. Good morning, sir. I am glad to have presenting vote of thanks towards respected Dr. Deepak Bhope, sir, for familiarizing us with mechanical engineering and and Professor Abhishek Kinhekar for technical support. Sir, I am really thanking you that you took out time from your busy schedule and make us know what actually the mechanical engineering is. Really, thank you so much, sir. Thank you and have a nice day.
Okay, thank you very much. Thanks all.
Thank you, sir.
Yeah, thank you.
So the next
So
session
the
will
next
start
session will start
after 15
after
minutes,
15 minutes,
and the link will be
and the link
posted
will
in
be
Telegram.
posted in Telegram.
Thank you.